Well, that's not right. The 12 here should be 14. Set nodes, accept support. And if you just pass a node, like N11, then that should construct a port from that node. And then just copy the ID. And that would be this one. Just a node. Yeah. A node is converted to a port. I don't think I'm using this. Probably never will use it. We'll try to compile that. Oh. Yeah, I'm just constructing a port here from a dot ID in an index. I'm using the dot ID of the node at index, but that's not what I should do. I should use the ID of the table node. In other words, dot ID of the base class. Yep, that is correct. Now let's fix the labels. The labels are now hello. But they should be table element. I think I should get a label from this node here, which is a graph item, so I can call the all the way up here. I need to get the data, and then we have this thing, which is this thing, which has an attribute list. We have to call attribute list on the data member of node underscore dot data dot attribute list. And then the attribute list let's just write a get. Hello, A4. I don't think I'm allowed to call data here. Probably have to just add table elements to the growing list of accessors. Or, no, not really accessors. Friends, I meant. Yeah, let's implement it. I need to create an attribute, which I'll call key. Well, I already have a key. Attribute key from key. And do find key, find attribute key in attributes. Which returns an iterator. Shall I do an assert or probably should do an assert. Con type iter is unequal attributes and No, let's not do that. Let's just say if it doesn't exist, and then let's just return a default value. Which is that a keyword? I just can't return a reference, I guess. Okay, so if this iterator is not equal to n, then it points to an element of attributes, aka an attribute whose key equals to the key that we were looking for because of this. And then I need an accessor for this string. Now let's combine that. Then I need to be able to construct an attribute from a key. Guess it's just no, that worked. Hello world foobar. Nobody knows why. It seems to be. I would say there's one pixel thick line away here from the bottom, but I guess that's a result of dot, of course not of the fact that the label would be wrong. So the label that I just showed is, although they are equal to these values, no, that's correct. But they come from nodes like, I think, probably 11, 12, and 13. Which are not shown. Maybe I should show them here and then make them invisible. And then you see the attribute list. It's not really required though. Maybe I should not do that. So now we only have labels. The stuff that in the text in this TD element is a pure text, label text. There is no color. Maybe I want to change stuff like font or font color. Let's ask ChatGPT, hopefully that it knows. What is this about? Something else. Ask it here. around. It's probably better if I really have a good method to detect if a certain attribute exists, instead of working with that default value. So you can test if an attribute like color exists, and if it does, then insert a certain HTML. So for a start, those attribute list. Let's do bool has value. No, has key. I'll make this by default something that doesn't have a default. Can still support this, I guess. It's an inline, whatever. It's a bit short. Make it get value. Now this value here, we look in attributes, it stores an attribute which actually has a string in it. And this returns a string const reference. So definitely can return a const reference now. I had a feeling that this would even work without that. It's just going to convert it to an attribute because find takes an attribute. Let me have a look. Discord. Yeah, that's also assembly, right? No, you have to do what it says here. Extend it for your CPU. Do you have whatever M1? I never heard of that before until you said it. You need to have some kind of define that shows you that that you have that CPU, I think. And then detect here that you have that CPU, and then implement CPU relax. I wouldn't comment it out, no, that's not a good idea. No, you need to know how to detect that you have an M1, and then how to insert assembly in it, how to on that CPU replace what is it, pause, I think, for the sake of CPU relax. You have a tight loop, and you don't want to block the, what is it called? Yeah, all the buses, whatever, data bus, address bus. Do the research. I mean, I'm not like, I'm not saying, figure it out, it's your problem. I'm saying that if you want to help me with the project, then this seems to be the most logical thing that I leave to you, because it's related to a Mac, and I don't have a Mac. So the only thing that you know at this point is that the assembly instruction is for, I'll have to look it up. Let me go to, how many consoles do I have open? Probably nothing. Nothing else, really. Yeah, here. Linux viewer. So you have something like a tight while loop, which waits for the value of some atomic. So I read a value from an atomic in a tight loop. That's blocking the bus. I mean, it's like, it's so heavily, if you do that at super high speed, then you get something that the CPU wouldn't like. It's not described above here. Okay, so it says, because this only reads without trying to write anything, and because of the widespread use of MESI caching protocols, this should cause the cache line for the lock to become shared with no bus traffic, while the CPU waits for the lock. Nevertheless, we add a call to CPU relax in the loop because that is common practice and highly recommended anyway by the Intel user manual. But you don't have Intel, so now you have to figure out how to do something like this on a Mac, and that will require research. I cannot help you with that otherwise than that I would have to do the research. But surely it has been done before in the world by people who own Macs or write code for Macs. That's the whole idea. And then I looked in the Intel manual and find out that the way to do that is this way. Here you see that I have defines. As if you have a 64-bit Intel CPU or 32-bit Intel CPU, then one of these is defined, and then we get here. You must have a define like that too. So you get something like else if defined whatever M1 do something that does compile and that is usable in a tight loop. It's research. I don't know. It must be somewhere on the internet. It would be really surprising me if there is no information whatsoever on the internet about this for a Mac. Yes, obviously. I mean, you read the end if now, and that's not good enough. We need to define. But not, I mean, you also need to keep the, please, you need, yeah, what I just said. If you have an M1 CPU, then or you figured out something that works on a Mac, and then you say, okay, this does not just work for a Mac, it works for that whole set of CPUs. So I test if that CPU is currently being used, then we're happy, and otherwise you still print that error that the next person has to implement it. That does have yet another CPU. Use one Nicola identifier attribute key. Oh wait, there was a key. I'm just going to pass a key here and hope that we create an attribute from it. No matching member function for call to find. No, it's not. Function viable. No known conversion from standard string to standard set blah 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 key type, aka CP attribute. What? So it says that there is no viable conversion from a string, standard string, to an attribute. Yeah, and then again, same thing. I really don't get that. Why would it not simply convert it? Oh, an attribute takes a string view. Yeah, might want to keep my string view as well, but also a string const reference. Let's see if this compiles. It's happy. No, it's not entirely happy. Of undeclared identifier assert. And then I would say maybe somewhere I'm also passing strings, two strings. Who's constructing this attribute? Add attribute. Yeah, ridiculous. Okay, since C++ 17 we can move in by R value. Insert 7. If nh is an empty node handle, does nothing. Otherwise, inserts the n element owned by nh into the container. Node type is not what I thought it was. It seems. Sure. Well, I have no clue. I'm going to use standard move though. No, that won't work. I need an insert that takes a, what is it? A node type? What? What? What is node type? Is node type is no. Node type. Specialization of a node handle representing a container node type describing the result of inserting a node type. Yeah. Guess it's just this one. 2. Insert a value. Without talking about our value. Okay, so we have an insert with value type, or that is called value type here, and on this page it's called value type. Value type is also a key. Key type and value type are the same thing. So you can use a move then, standard move. And then I'm just going to use an R value reference, right? Or not. Well, both, I guess. We need both. I might as well make this one inline. Why isn't it already, you would say? Let's begin with this. Just comment that out and then see where we go wrong, because we only can move. Probably somewhere I need to construct and then copy an attribute. But if we can avoid that, that would be nice, right? Because it contains two strings. So copying a standard string is kind of expensive. I mean, not in this case, but it would be stupid not to do it. Not to write the code in the right way, even though we don't care really about how slow it is. I still want to do it in the correct way. And then I forgot again what I was doing, so I'll just have to compile and then see where it goes wrong. It goes wrong everywhere. Extra qualification on member add. Whoops. Binding reference of type attribute to value of type const attribute drops the const qualifier. Why would it even be able to do that? Yeah, let's try to move everything so long as we can. I think the route where you just move should exist. And then we can fix the cases where there's just nothing to move. Afterwards, add new path where at some point an attribute just has to be constructed. Binding reference of type attribute to value of type const again drops. Drop. Or no, that worked. Strange, I would say, but or not. So what happens now is that the user is just passing braces, so initialize a list, and the function takes an R value reference to an attribute. So then what happens is it says, well, we have an initialize list and we need an attribute. So I construct a temporary attribute, which is then automatically an R value. Done. It constructs here an attribute, a temporary attribute, which then is moved all the way into the target or place where it is actually stored in the stand set. Yeah, no. So here I explicitly extract a label written like this because I need a label. And a label is implemented with a call to the get function or the attribute list. So it just searches for a key label. And now we pass a default value here. So I get no label if no label has been added. Well, you kind of always need a label, so I think that's good enough here. But you could say add, let's say, a background color, like GPT-4 said here that we have. Table has a border. We already used that, and a cell border. Already used that. Cell spacing, we already set that. Cell padding, we already set that. And then we have the background color. That's a table background color, which is very much the same as the dot background color keyword, which already exists and which we already use. So I think I can even show that. Background color. Oh yeah, you can add a dot keyword background color with some color as an attribute. Therefore, well, that's kind of logical that we make a one-on-one correspondence with the HTML supported background color. That background color is then for oh great. No, well, we are there. So the background color, adding it to the table would make the I think the whole table same color. It's kind of the attribute, I guess, of the table node then. So the table node is just a pointer to the table node data. And then the table node data has attributes stored in the graph item data. Or rather in the graph item ID. Here's my attribute list. So I can get the attribute list from the base class graph item ID, which is the base class of graph item data. So we can call it on the base class graph item data, which means it's that member function still exists here. Table node data, you can just call it. And this is table node data. So at this point, we can just call attribute list. And then we can do has key background color. And then I can say print, well, all of that, why not, all the way up till here. And then we start over. Really? Okay, so now I can make, say, this whole node. I can give it a background color, let's say red. Yeah, red. And that would be my table. The table node. So I think I can do table and then, I don't know, something. And then background color, comma, red. And that would be, I guess, an add. I mean, how do I do that on the node? Simply add attribute. Not sure that will work on the table. So a table node, I don't think add attribute exists for a table node. Maybe it should. This is just craft item. Yeah, we just have. Oh, I do have an add attribute here. Yeah. Yeah, okay, immediately supported. Simply call add attribute. And then it's red, including that thing at the top. Oh, that's highly annoying. Oh, that's highly annoying, yeah. I added an invisible cell at the top to avoid the arrow coming from above if it wants to point to hello. I want it to point to the side always. is it? Can hardly believe that is a real color. But I guess we'll test it out. I can just test it out. Why am I in Linux viewer here suddenly? Let's test it out here. Transparent is a color. It says. Oh, nah. Nope, it's not. Yeah, need to think of something else then. Or I could remove the first, the invisible thing, but yeah, then I need to figure out another way to make all the arrows attached to the side, which wasn't easy as either. Hmm. Feel that it's all very limited. There's not much we can do about it. Yeah, well, maybe just not set the background color on the table, but set it on each element separately, I guess. So here I want to get the background color, I guess. I'm just gonna do the same thing as there. Elements. But wouldn't it be nice to just get the whole attribute list of that element? Now I'm calling a label here, but you have to test it as well if it exists. I think I just want to get the attribute list of the elements. So let's try to get it like that, and then has key. And then again the same thing, but then not hash key, but just get value. So that should work if we could have an attribute list on whatever elements port returns. I think elements, it's a table element, so table element must have now an attribute list accessor, which looks like normally like that. I just need a const one in this case, so you can just add that as an accessor. And then return the attribute list in the same way as we did that here. That should work. And it doesn't. At least something goes wrong here. I don't have any red elements. Why not? Wait a minute, I just wrote to graph.dot. How does the thing look like? There's a background color here, just ended up on the wrong place. Oops, yeah, that's nonsensical. I need to write, I think, TD port quote and then continue later after that. That's better, right? Yay. So now I have set the background color of my table to red, and then everything is red. But let's say I'm going to set foobar now to yellow, give it its own background color. How are we going to do that? Wait, I need to go to... Yeah. So I'm going to do v1, 2. That's the last one. And add an attribute background color to set of green, yellow. What the hell? Why the hell would I be able to do this and not that? What? Oh, okay, sorry. I need an A index. Just create an official one. Even more official. I think I can subtract one. Well, then again, maybe not. Don't think this works actually. It works, amazing. So now the last one is yellow. Yay, that worked. Okay, so what else do we have? We have so now I have a background color that works for the whole table, but just by passing it on to the background color of all the TDs. So did that also work then? What else do I want? I think I want to have color working. Then normally, if you set color, that changes the color of the text, I think, isn't it? Or doesn't, or isn't it? Try that out. Let's see, N11, and I set an attribute called color. Set it to purple. in 11. Aha, so indeed, the color is the outside. Interesting. So that kind of matches then this color. So it's the table border color. It's a cell border color. So what happens if I just set the cell border color of a single cell? It's not clear because it has boundaries that are part of the table as well as the neighboring cells. So what does get that color then? Let's try that out by just editing this file. Let's set the one at the middle. Color is purple. Okay. So it draws that one of the top first is black, and then this one is purple, I think, even at the edge. And then foobar is black again, so it just rams over it. Not very nice. Not very nice. Can I blow this up? Up. No. I think the sides are purple. So probably just draws the whole table and then the cells. And then the cells goes from top to bottom. So I would say, if I say color foobar or the one at the bottom purple, then this is the whole square, the whole rectangle, I mean, is going to be purple. And if you do hello, then just this U form. Just the same as here. I guess it's going to be purple. Let me try the one at the bottom. Mm-hmm. Mm-hmm. Yeah. Something like that. But got the feeling that I might as well support it. And then definitely also support the whole table. Having some kind of color. Then I suppose everything becomes the same color. Also the lines in the middle. Yeah. Yeah, col span or row span. Don't think I have a good what's the word? Let's say use case, whatever. I don't think I have a good use case for that at the moment. Align via line, nah. BR I do. Font. Yeah, text color, right? Want to be able to set text color. The font family as well, I guess. Point size. Okay. Hup. Yeah, that doesn't work like that. That does not work like that. We have to edit each thing separately. Each element. So I'm gonna say like if. Need to do the same thing, right? Each time I make an abbreviation of the bloody attribute list here. Yeah. What was the name? Font name? Font name? I don't know. Font face. Now, let's think. I guess we have to test this with setting a font name and a font size and a font color. And I can begin doing that on the table. Let's just use these things. I'm not closing it. Let's see, there's an extra font around the hello, which closes here. There's no space in front of color here. No space there, and there is no closing angle here for the TD. What a mess, ish. Expect that to be the one. Oh, I'm an idiot. Oh, wait a minute. Yeah, this is nonsense. Let's make that again. So that's a closing thing that belongs to TD. I don't need it here then. And font opens here and closes here. I think this is better. Well, it looks good, I guess. Although I can't see what the color is. Let me change the background color to light blue. I don't know. Well, at least the text color is okay. I'm not sure about the font. The font size also seems to have made it. Well, this is kind of larger than that. I'm not sure about the font name though. It's different from, this is a non-sans, as it were. It's a little foots for the N. But I did put it in though. Well, now we have two spaces here. Yeah, no, at least the C++ code is correct. Apart from the space of the font. Now we have those as well. I'm not sure I'm getting it. I'm reading this here. Shape is plain so that the size of the node is totally determined by the label. So apparently they just set everything to 0 and then it grows, I guess, to still contain a label. Therefore it is totally determined by the label. But then it says, otherwise the node's margin width and height values may cause the node to be larger. So if you have no text or very little text, so that the edges are clipped away from the label. Is that this effect? We can't see that anymore. Not like this. What we had this bottom full bar. I had the feeling that something was missing here. So let me restore them to the not setting a font. Not setting, well, let's not set that, and not set that. Not set that, I mean. Yeah, see, so the bottom is, well, clipped away, whatever. And now they say that if I use shape is plain, no need to set that anymore then. That would fix it. Doesn't. Looks as horrible as before, if not even worse. What did I do? What did I do? You put the height in here and everything is changed, not just that one table. Well, it makes no sense whatsoever if you ask me. The larger you make it, the less you can see. I don't think it's a good idea to set height at all. No, but hey, now I do have the full text in here. The size was in inches, I think, so, well, maybe. Size was in inches. Can I also set like 0.1 then? Still have my foo bar. And I set the height to 0.0, then we don't have it. Nope, it's not clipped. Oh, the problem is setting the margin to 0. No margin whatsoever. Yeah, that's probably not a good idea then. Margin 0.1. That looks already good. No, I'll go for 0.1, I guess. Suppose it might depend on the size of the label though. So we change the font of the bottom one to have a point size of 18. I don't know what happens. Still looks reasonably. No problem. Wait a minute. Okay. Read the chat. Mantra, hey Carlo, I hope you're doing well. I've been learning C++ lately. Do you have any project ideas that would challenge me and make me learn more stuff in C++? And then you talk about web servers. It's pretty difficult. Web server. It's more networking than C++. Of course, C++ doesn't have native support for anything like it. Yeah, I don't have any good ideas off the top of my head. Do you want to get a good feel for? Oh God, there's so much to learn in terms of C++. I would say, I started writing a program that printed prime numbers, but it's hardly. That wasn't C++. It was written in BASIC when I was 12. Don't use boost ASIO. I hate that. I hate that one. Oh well. What shall I do next? Let's commit to Git. Status VR ports. The new files look as follows. Oh, I have no idea why this is here. Why is this here? Node.hpp. Yeah, okay. And then we have here attribute list. You can access the node of the node table. Or the attributes list directly. Did I ever use that I can access a node? Well, why not? Oh well. Got big. It got big. Get diff. Include an in .cxx. Make that a for declaration. Why not? Several ways to construct an attribute. Yeah, well, also why not, I suppose. You gotta wonder which one it picks if you pass a caret const pointer. You know, I have no idea. Let's test that out. Motherfucker, don't touch my clipboard. That's so annoying. I'm lazy. Let's just make a struct for this. Loads of warnings. There's an error. Yeah, it's ambiguous. Well, that's shocking, because that means that get rid of the warnings, because that's annoying. Still. The whole idea of the string view was to use it. if you pass a char const pointer. Sure of that. Sure, I have to kind of put S symbol for a string. What do you mean? Like this? What would that do? S was not declared in the scope. I don't know what you mean. SV maybe. Let's see if they have an example here. Put SV after the string, you mean? Well, I have to admit I didn't know that. I didn't know that. So, well, maybe that's a better solution then. Oh wait, you know what? Unable to find string literal operator. So didn't really help then. Sorry, but now I'm lost. Value type info. It's an operator. So here they seem to be constructing a string view from, well, that literal here, and then actually getting something of 8 characters, despite the embedded zeros. Maybe string view has an explicit constructor and not an implicit one, so we cannot do that. I would have to look at string view itself. Or that's what you said, right? Yeah. Let's try that. Aha. Yeah. Yeah, sorry, I didn't get what you meant, but then I saw it as well. So this namespace contains SV operator-ish. This is completely new for me. new to me. This kind of stuff. I never use that kind of, those little operators, so they add to strings and stuff. I never use that. Anyway, another solution would be to also add a char const pointer. I guess the main downside of this is that it might call string len on it during runtime. Yeah, but you need this, so it's not entirely the same. So I could do this. Let's just show me that this works as well, right? I think you can cast it to string view, character const pointer, and then of course it's gonna use that that one. So that works as well. But yeah, okay, so there's two downsides. I think that this is going to, well, if you do use optimization, it's maybe seeing that it's a string little and going to be smart. But in general, theoretically, you would just call, I guess, string len on it, maybe, I don't know. And definitely going wrong if you embed a 0 in it, and then of course it's going to be just 4 characters. Well, if you use the SV trick, then you get even the embedded zeros in it. I think it's gonna call string len on it then. So that's why it stops at the first 0. So is this ugly? Maybe not. I like bleeding edge, so I won't do this. And then I'll force myself to use this from now on, if I want to pass something to a string view. But I'm not sure about it. Yeah, because sometimes I already have a string const reference. You mean a standard string converts to a string view? Easily, right? Implicitly. So I don't need that. That's what you're saying. Yeah, you're right. I should just remove this, and I don't know why I added it. It's a good remark. Let's say I have an S, which is I'll pause that. So I'm not using this one, but there's no good reason to have it. Yeah. That compiles as well. Okay, I'll just throw that one away. I think that's the best solution here. attribute.hpp. Yeah, because I have to make a copy anyway. So it doesn't matter if you make a copy from a string or from a string view. A copy is a copy. And if you pass a string, then it's the same number of CPUs, probably even the same assembly code. So it was just stupid that I had that. And now what? No matching member function for call to find. Oh. Okay, so that was the reason then, maybe? Because now I have a string const reference, which I pass to the find, which takes an attribute. And for some reason, it's now not willing to turn that into an attribute. So my guess is that the string view constructor that takes a standard string is implicit. Or I mean explicit. So let's have a look if that's correct. I want to go to string view. String view. String view constructor. No, that's strange. Explicit. R value is explicit. No, it's C++ 23. I don't have that. I don't get it. Oh, this is string view. Wait a minute. I don't have a string at all here. Okay, am I crazy? I am crazy. I'm looking at the wrong thing. Sorry. So stupid. I'm meant to look at the constructor of string. So a string can be constructed from a string view, not the other way around. No, you have to find the back. String, 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 string. Character const pointers. Iterators. String view like. Templates. And they are explicit. 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 These are not explicit. This until 0+, so this one. But then you have to pass the size type as well. I'm not doing that. Pos and n, nope. Nope, 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 nope. This is the one that I try to use. That's explicit. That's why it doesn't work. Okay, well, so do you have an English name? Not that I can remember it, but I cannot pronounce your name, so. I mean, I can of course construct an attribute here, and then it works. But I'm wondering if there is another way. You say maybe you can use data from string view fast with move semantics. Dima. What do you mean with why non-standard find? Attributes is a standard set that has its own find, doesn't it? Standard find would be a linear search, I think. Anyway, I'll just make it explicit. So I didn't want to do this. Construct explicitly in temporary attribute from the string. And that's why I added a constructor of attribute that takes a standard string const reference. But if then it's ambiguous to pass a string literal, then yeah, well, we'll do this, I guess. I think that now it compiles again. Yeah, good. So I can continue with my commit. Yeah, but rather use the find on the container if it has it. I mean, the find on set is doing a binary search. I'm not convinced that standard find will fall back to that. Of course, not that we need that here in this case, but you should use standard a set find, I think, for a set. Okay, so we got rid of that, the constructor there. We have an access over the value. Well, not a binary search, but a tree search anyway. Exponentially faster. Is it exponentially? It's not logarithmically faster. I don't know. Yeah, anyway, you get what I mean. This key, yeah. The more senile I get, so the more risk there is that I do something really stupid. I used to check my git diffs by just looking for stuff like comments or spaces at the end, or fix me's, stuff like that. And now I'm getting more and more worried that I'm doing something really stupid and I have to really read the code. But yeah, let's not get worried for nothing. I do comment out something here and then left it in. There's stuff like that. That's why I look at the div. Should just remove that instead of commenting it out. Okay, so that's also not what I want. I want to use ID type with that. So it was correct. .id. Yeah, I even remember that like half a year ago, I think I was doing this, looking at the div at a pretty high speed still. And then I explained to the viewers that I wasn't even checking the code. I wasn't reading it. I mean, it went so fast that, you know, it was impossible to read. So I explained that what I was really doing was just looking at the div and then recognizing it, as in remembering it. So you look at it, I don't read it, I just see this, few keywords here and there, and then remember that I worked on it. And then together with the memory came the realization of, oh yeah, that was good. You know, I remember I did this and it was good. And that's how I used to work. I should still do that, right? Just not worry about what it actually does, but more like okay, I see this, yeah, that was that rename. Okay, well, this is a rename, that's pretty clear. So we can go much faster, but I think my memory is really going down. So now I'm looking, I can't even look at the div and then not remember it anymore. I cannot remember that. Did I change this? Well, things slow down dramatically, of course. Well, maybe the reason that I don't remember this is because I had no idea what I was doing. Or just fixing, I just threw some mud against the wall and then it started dripping down, and then I fixed the compile errors without understanding what I was doing. The only thing that still worked was knowing how to fix compile errors. And then we ended up with this code. So now I look at it and then it's not like, yeah, I remember what I was doing. No, I was just fixing compile errors. Yeah, well, whatever. Let's scroll faster. Another method is also that you see a red line and a green line, and they more or less look the same, and then it's okay. Yeah, like this. These two, well, I mean, what can go wrong? I did add something here. Write all tables. Okay, yeah, well, it has to be done. I mean, it looks green. Yeah, that's a joke. No, not. This I still remember, you know. I see this and then I think, yeah, I moved that to another file, so that's why it's gone here. And that's renamed to .id, and here we have stuff that is removed, which I don't, oh no, that's not removed. It was changed. Yeah, now attributes are being moved. Table node is, yeah, that was a pretty big mess. In the end it compiled and worked, so I think I can just commit it, alright? I should look more for things that are like obviously wrong, like the things that we just fixed. Yeah, my concept comes back. I changed table node into something else which uses table node data. So it's almost a rename, I guess. So I wanted to say table node, change table node to something that is derived from graph item. But I couldn't remember the word graph item anymore. Okay. No, it's good enough. Even the commented out stuff, I don't need to comment that in at the moment. So git add these things. And then git commit minus everything. And then the main changes is that I added, I guess, new files, add port and table element and stuff like that. let's mention all the class names. Table node, table element, import. Yeah, an ID type went to dot ID type. And then the sentence just becomes too long. Sorry, but that's it. Okay, push. Look how clean it is. Oh wait, it's not clean. No, yeah, almost. It still compiles even. I tested it before I pushed it, you see. Okay, so the next thing that we want to do is maybe I have to look at my description. My YouTube description written days ago, in which I said, I guess I'm going to write a C++ library to create and draw graphs of relationships between C++ objects. Haven't done that yet. Obviously, a single object is a vertex in the graph. Then an object pointing to another object is a directed edge. Yeah. If an object is contained in another object, it has edge. A has edge should be drawn. So there are different types of edges, and they come about by either pointing to them or having them. How am I communicating that to this code? Maybe I'm not sure. I think what I wanted to do is first finish the visualization of it. So make any kind of C++ interface with GraphViz, or rather something that generates the correct dot file. And then build on top of that, yeah, something that does what I want. Let me continue reading. If I need more. Oh, well, I do need different edges, that's clear. If an object is contained in another object, a has edge should be drawn. If an object is the base class of another object, then that requires its own edge, I guess. So we have also an is derived from edge, even more types of edges. If an object is stored in a container, then the container should be a subgraph and be treated as an object on its own. Well, I made that. That's my table. So a table node is a container with stuff in it. Containers that are indexable, vector, deque, and array that have the same index should be put together in yet another subgraph. Using rows per index, and then index types can point to a row. All in all, so difficult that this warrants a different project. And then I started working on this. So we need different edges, and maybe I should test that, or get that work rather, if I have multiple things with the same index. One of the things that I have wanted to do for a bit now is use a single index for deques and vectors. So I have a vector index. Vector index is a class wrapping a size type, so totally an index, right? And I'm pretty sure that I have also a deque index. I don't? Oh, that's interesting. So I have a utils deque. Oh, it uses deque already uses vector index. By default anyway. I guess I can pass whatever I want. I can pass a vector index, why not? It doesn't have its own index, let's put it that way. Yeah. You just pass it. You can pass whatever you want. Then there is no deque index, so I guess that's already taken care of that. So we only have vector indexes, and then if two containers have the same index type, then I want them to be put next to each other. This is an invention of myself. So I don't like standard vectors, and I invented utils vector, which is derived from a standard vector. So it's just not much difference, but it defines an I begin and an I end, which returns index type, which is a type that is, yeah, not convertible to and from normal integers, just really type on its own, which you then can use for the square bracket operator as index, and also for add. For the rest, it's the same as standard vector. So I have a struct A here. Let's make a struct B. Need some kind of type, right? Different type. Also a node. Totally different type. But the A index is going to be used for a vector of A's and also for a vector of B's. So let's say we make another vector here with B's in it, but I keep using A index. That means that an index into V1 can also index into V2. Which implies that they must have the same size. So V1 has a size 3, V2 must also have the same size, and then if I have an index that points to, let's say, the second element here, and then you can use that index. So the index would be 1. This is index 0, this is index 1, and index 2. So index 1 refers to 4 if you apply it to V1, and 7 if you apply it to V2. So these two are basically the same. They belong to the same index. That's the idea. Because I use the same index type. So if now I make another table node, well, let me call my table here a little different. So I have a lot of tables, but they're all the same thing, so I can just rename them in bulk. Substitute table with table A. I'll make a new table. Let me put this down because it's new code, right? New code, new table. Table A, table B. And then we do add elements, of course. Table B, add elements, V2. Adding 1 should not work because, well, of course that works as well. It's just a name. But we're adding V2 with B's, that's why I call it table B. Now I have a table with B's, but same index. And I want to show it as well in my graph. So I need to do add table. Oh, that's not good. So let's add it to graph 0 as well. Add table node. And then we add that. I think it should already be visible then. Nope, something went wrong. Oh, that is funny. Yeah, it says here no level because I didn't add levels. But if you put that in the middle of HTML, you get an error. So I have to do something special with my labels. I must escape them. HTML escape. Let's do that immediately. That was table element, I think. No, table, something with table. I guess this. Yep. So I'm getting my label from here, label. I think I should do the escape here. I have no clue. Ask ChatGPT. What do people not normally call a function that escapes a random string for use in HTML? That's not what I meant. Oh, function names. HTML escape in Python. HTML escape. Okay. Let's copy it. Copy. Add an anonymous namespace for that. Totally local function. String. I'll probably already have a string. Need a map though. And I really hate it if people put const before it. All the other type qualifiers go after the type, except const. And then even only in a certain case. It's like, yeah, it's an exception. And I hate exceptions. It's not logical at all. I'll tell you, I wrote Björn Strustrup, and he responded even to me. So he said that he started writing C++ using read-only keyword. So we had a read-only int I, and you have to initialize it, of course. That's how he started. And then later, he replaced read-only with const. Not even, I mean, let's say this is English, you know, it is a read-only int. Okay. So, and then later he came up with the word const, and he just did a search replace. So he didn't read it, he just turned it into const. And then you got this. And then after that, he invented pointers, or maybe pointers are part of C. Okay, pointers already existed. So that he say, well, okay, I have a read-only int, and then I have a pointer to that. I mean, in C, they wrote that like this. Like that. You know why? Because in C, people got used to making multiple integers on one line like this. And if then you want j to be a pointer, then you have to put the pointer there. You can't put it here because then I, j, and k are suddenly pointers. The solution for this is that never ever declare multiple variables on one line. So you just don't do this, do this. And now you can put the star against the type. Why? Because it's part of the type. It's nothing to do with the j. Well, it has it's a type of j. And now it still remains annoying because you have to read the types right to left. This is not an int pointer. This is a pointer to an integer. So you have to read it from right to left. Now, if the integer is a constant, you are allowed to put it here, and now you have a constant integer and then a pointer to that. But it's exactly the same as this. And if I read my types from right to left, I think this is way easier. You just have a pointer to whatever is on the left, which is a constant whatever is on the left. I mean, sorry, but if I want to change my integer to an integer pointer, that works. That doesn't. Now they are different. Why? Because this const works on everything on the left. The star works on everything on the left. This is a pointer to whatever is on the left. It's a pointer to a const, pointer to an integer. This star also works on everything on the left. This star also works on everything on the left. So this is still a const integer and then a pointer to that and then a pointer to that, which is not the same as this. I think that this is the exception. So why not put all qualifiers on the left? And now you clearly see the difference. This is a pointer to a const int. And this is a pointer to a const pointer to an int, to a non-const int. Okay, long story short, I fought a battle against people to ban putting const in front of it. I even wrote a patch for the GNU compiler to report errors with const on the left. And they refused it because the compiler coders are C coders. And C coders are just used to writing stuff differently. They write const and then they put the stars against a variable, and that's just grown from 1970. I mean, they just old people who just like me, but they just can't do anything different anymore. And then C++ a little later, and there's more qualifiers, and C coders, they put it against the type. But this const, it remained where it was. Yeah, come on, man, just put it here. Bullshit. Super annoying. Yeah, they didn't want to do that. So now we have compilers, C++ compilers, that spit out errors with the const in front. It's even so bad that if I ask ChatGPT to write something, then it puts the const in front of the string. It's going to be a legacy for humanity that we can never shake anymore. Makes me sad. But okay. Me and my viewers put const on the left. Yeah, all the qualifiers. Put all the qualifiers on the left of what they work. Sorry, on the right of what they work on. Qualifiers work on everything on the left. So you put them on the right of what they work on, including const. Thank you. Feel free to do this if you like that, but the reason I put my braces in the same column is because I don't care about that one lost line. Okay, I mean, I've used a pretty large font now before YouTube, but normally my font is such that I have a... I find it more important these days. I mean, I started coding too when we had only 24 lines on a monitor. Like 40 characters. The first terminals were 40 characters wide and 24 lines high, or less, I think. 22, 23. And a status bar. And then you had to cram everything together and really watch out where you put your spaces and your new lines. But be honest, if you have enough, if your monitor is large enough, then it's really advantageous. What is, how do you pronounce it? An advantage to put your braces in the same column. But okay, that's just me. And then what I do hate is wasting 2 lines while I have only 1. So yeah, I want them in the same column. But this way, I have 2 lines wasted while the contents is only 1 line. So then I just delete them. And that way I get my style. Well, let's assume that GPT-4 wrote this correctly for the rest. I really don't like that this map is being created every time we call this function. Over and over and over. But yeah, put it outside. It's going to use a little bit of PSS sector. What is it? Maybe you can make it const at least. I'm not even sure if that's possible. Probably map is using malloc, right? It's going to put stuff on the heap. Okay, I'll leave it like this. I mean, it's gonna be, well, in my eyes, this is like super slow. Every time you call this, you create a whole map. You call several times malloc probably, or no, okay, probably just once, but still, you call malloc. It's super slow. And then you're gonna do you're gonna use the map, which is also slow. It's a really, really slow function. But okay, it's here in anonymous namespace in just this file, which is basically written for debugging purposes. When I write code that must be fast, I look at nanoseconds, and then I write it such that it takes a few nanoseconds. And then sometimes you have a case where you can do that and then put several weeks into getting a code that is executing in a few nanoseconds, or 100 nanoseconds. Well, if you would not have put in weeks into it, but just days, you would have gotten something that took 100 microseconds. But you would never ever notice it, because 100 microseconds is also very fast. But I've often made that mistake. I always want to write the fastest possible code. And when I see code like this, which I didn't write from scratch, GPT-4 made it up, I'm like, what the hell? I would never use map here. Never. Never, ever, ever. I would just hard code it in probably. Just run over the characters and then check if they are one of these. No map, just hard code it in the code. I bet that would be faster. Yes, static would be faster in the sense that you don't have to construct a map every time. The downside then is that you'd allocate a little bit of memory on your heap and then never free it again, which also has a little bit of downside. You know, maybe you fracture your heap, so you have less efficient memory usage. Well, if it is hard-coded in, it's part of this code block. So at the moment this function is executed, this is read into the cache, and then you have everything, including these characters here, and these characters there, for that matter. Well, they're probably stored somewhere else. But then at least these characters are just part of the program that you just wrote, that you did just read into the cache of the program, the executable code. Let me try not to look at it. Okay, so we have an HTML escape. Let me add that around this label at the very least. So any other things that I need to escape? I think I should probably, you know, if you talk about if there is any danger that crackers or script kiddies, or how do you call those animals, would try to attack something using this interface, then of course you have to escape whatever is the output of get value. That would not contain a sane value like red or green, but some injected HTML code. That is possible this way. So yeah. In all reason, I mean, if you want to write safe code, I would have to pass this to a function that makes sure that it doesn't contain any quotes. So it would at least be a string. Maybe limit the length also to something sane. But I don't think that we are at a risk of it's just a dot file, right? So what can you do? You can completely corrupt the output graph, but yeah, I don't think it's safety here is a concern at all, actually. So now it says neatly no label here. So you have to add labels. Wait, that would be there. Oh damn it, I have to make dinner. It's 8 o'clock. First, second, third. Okay, but the whole idea is now that since these two, this table and that one, have the same index, use the same index, I want this one to be at the same height as that, next to it. So you can see at once that they have, you know, the same index. And then if this one is an index, it can point to both at the same time. And I can do that by putting those two in a subgraph. And I think that the subgraph then can have a label, and I put a label above it, and that then spells out the type. So in that case, I want to have the word index A here, and then that table below it, and then a nice square around it, a rectangle around it. But I have to go cook dinner right now. It's getting very late. Probably continue to do this tomorrow, and then I think I'll get that probably to work. It's part of the work of tomorrow, and then we'll have that thing. And then next I need to make index. Sorry, my edges must be of different types. Inheritance, pointers, and has. So has it something? The class has a member. Edges. And then we're done with generating the dot files. So then the next thing is to make a layer of classes on top of this. And that will make it easy to actually get that structure out of the C++ structure that exists. I still have to think about how to do that. On one hand, I would really like to do it non-intrusive. That is, you just have C++ code, and then without changing the classes of that code or even adding a lot of code, get your graph anyway. But yeah, I don't know. It's not going to be very easy, I think. I can derive all my classes that I want to appear in my graph from the node class. That wouldn't be too intrusive. But let's say if I have a class that is derived from another class. Okay, I'm talking about it anyway. Let's say we have a class or struct C, which is derived from B. Now B is derived from a node, so now C is suddenly the same node as this B. So is it now a B or is it a C? And of course it is a C. So yeah, then this thing must learn what this label is from the fact that it is the final class. So I cannot think of a better thing to do than just implement an overridden vertical function that returns the label. Yeah, Kertkins. So return. Let's return the string view label. Const final. But it's not final. This is final. So I mean, then if I make this one final, I cannot override it again. Just make it override. Override of vertical function in node that is overridden here. And then I'll say return, well, I don't know, B, that would be the label, I guess. Not even sure if it compiles, but we just looked at that. I think it was implicit. Yeah, so it should work, I think. Otherwise, I'll just add the SV there. Okay, so this one would give me the label B for every node B. But then this one must get the label C. Okay, I'll make it C, no problem. Rather, that will get the label B and this will get the label C. But I talked about that I wanted to see that C is derived from B, right? So I want to show B as well. I want to show B, and then maybe draw an edge to the C. Or is that nonsense? Maybe I shouldn't want that. I guess you can make C a subgraph that contains a node B. And then B doesn't really need a label anymore because it's simply yeah, I don't need to call it. Wait, this is nonsense. This is nonsense, I think. I mean, the label, this is the type. I must, of course, have an instance. So you have to pass it somehow. That's what I mean. I mean, if I even change the constructor and demand that I pass the name of the instance, that would be horribly intrusive. Because now I have a constructor of a derived of a derived of a derived class. And then in the end, I must end up in a constructor node. No way. So the only way we can do this is by, let's say, B set label. Yeah, if not like this, of course. I mean, it's now at global namespace level, but we can do this in a function somewhere. That is less intrusive. So you just set the labels, okay. Probably don't want this if I can avoid it. No virtual functions. Something like this, maybe. But yeah, in the end, I think I still want to see a rectangle for C, like this, with everything in it, like all the members that are nodes themselves, as well as a rectangle for the base class. But I would not require an edge. That's more like this is a subgraph and then that's a label inside it. So you get a node inside the subgraph. Okay, maybe just subgraph C. So I don't need an edge for inheritance then. And then the same thing for has. I don't need an edge for has either. If I have an A here, then C has an A. But I can also do that by making a node of the subgraph C. It's just different for pointers. If I have a pointer to some A, then we really have a different A. So then somewhere outside I have an A with its own label. And then in my graph, I want to see a rectangle with a label C in it, and then an edge that points to a rectangle with the label A in it. Because that C is pointing to an A. Or maybe I don't need different edge labels and edge forms. Just one edge for pointers. Okay, I'll I'll be back tomorrow. Thank you for keeping me company, and I'll see you guys.